Good afternoon, ladies and gentlemen. This is Mr. Riddle. We're going to review and talk about Lesson 14, Composition of Functions. I'm going to explain to you what a composition is and how to find the domain of a composition. So what is a composition? So basically what a composition is, let's say for example we have two functions. Let's say f of x equals 6x plus 2. And we have a second function. And g of x equals, let's say for example, x squared. What we're going to do a composition, and there's lots of different compositions we can do. We can do one called f of x. It's written like this. Not fog, but f of x. So that would be called f of g of x. That's equivalent to seeing it like this, f of g of x. And we can also find the opposite direction. So we can find g of x. So that's written like this, not goff, but g of x. G of f of x, and that would be the same thing as g of f of x. Okay, so what is it? Well, if I were to do f of g of x, for example, what I'm going to do is I'm going to replace x in the target function with the expression from the other function. So this will be replaced into g of x. So that's the way it's going to work. So in this example, if I were to do f of g of x, what I'm going to do is everywhere I see x, I'm going to take this and put in it and then you simplify. So what you end up with is a new function that is a composition or a put together, if you will, where you put both the functions together into one new function. So that's what a composition is. So let's go through these examples. Here we've got f of x equals 2x plus 1 and g of x equals x plus 3. I'm asked to find f of g of x. So in other words, I want to replace x in f of x with the function g of x. So I want to put this into that function. So again, whenever I see x, I'm going to replace it with the function from g. And then I'm going to simplify. Now to simplify here, we have to distribute and combine terms. So I'm going to distribute. Then I'm going to simplify. These two terms combine, so my composite function is 2x plus 7. So f of g of x is that function. So now you're also asked to state the domain. Now the domain tells you what x values you can use in the function. So now in this case, and you can always use your graphing calculator to kind of help you out here. If you were to put that function into your graphing calculator, you would find it's a linear equation. That's kind of a quick sketch. So since it's linear, that means you can use any value for x. So the domain, in this case, the domain would be all real numbers. So there's your composition, and there's your domain. Okay, here's our next example. This time we've got f of x is x squared plus 1. We've got g of x equals x minus 1. Again, we're asked to find the composition, f of g of x. So we're going to replace x in f again with the function from g. So this goes in for x. So again, I want to use parentheses every time I substitute, just to remind me that I've done a substitution. Make sure when you show your work, you show this step. Don't show your work. Remember, I'm going to ask you to do it again. So now, what do I do here to simplify? Well, I have a binomial that is squared. So I'm going to have to use multiplying binomials, the FOIL technique. So I'm going to do that part first. X minus 1 times x minus 1. Use FOIL. So first, x times x is x squared. Outer. X times negative 1 is negative 1x. Inner. Negative 1 times x is negative 1x. And then last, negative 1 times negative 1 is positive 1. So I'm going to finish up my composition here. I'm going to combine those two terms together. That gives me negative 2x. So I've got x squared minus 2x plus 1. And I still have this plus 1, which I haven't used yet. So now, to finish up my composition, combine anything that combines here. Those two 1's combine together, so my final composition function, x squared minus 2x plus 2. So that's f of g of x. So that's my final function. Now again, we got to state the domain. So, if you're not sure about domain, remember it's always what values you can use for x. And again, don't be afraid to use that graphing calculator. If you were to graph this, excuse me, this is going to be a parabola. So again, a parabola is continuous both directions on the x-axis. So there are no excluded values. So again, the domain is all real numbers. So that's example 2. Okay, here's an example using a square root. So we've got a radical. Again, we're asked to find f of g of x. So again, wherever I see x in f of x, I'm going to replace it with g of x. So all that's going to be under the radical. And I wrote those numbers backwards. So that is x minus 4. That was my substitution. n minus 3. Simplify what you can simplify. Here the parentheses aren't really necessary, but I can combine those two terms together, so that gives me the square root of x minus 7. So that is my f of g of x. Again, state the domain. Now this one has a problem here because we have a radical. If you were to kind of look at the graph, you will notice that it kind of does like that. It's a single half of a parabola. If you were to graph it, so that means there's going to be some limits to what x can be. And to figure out those limits, we're going to set what's inside the radical equal to 0. And so if I add 7 to each side, I'll see that x equals 7 is the critical value that gives me 0. I can't put anything less than 7 in that radical. If I were to put 6 in, for example, 6 minus 7 is negative 1. I can't take the square root of negative 1. So when I state my domain, I have to take this into consideration. And so x would have to be any value that is greater than or equal to that number. So x is greater than or equal to 7. Okay. And one more example. This time we've got an exponent, or to the x power, and then x to the third power. So we've got a variable as an exponent this time. And instead of finding f of g of x this time, we're doing the opposite, g of f of x. You can find it either way. It doesn't matter. Just pay attention to what you're being asked to do. So in this case, we've got g of f of x. And this time, I'm going to take x right here, and it's going to be replaced by that. So we're substituting this direction. So we've got x, replacing that with 4 to the x power, and then I'm going to cube it. Now, how do I simplify this? Well, we're going to use the rules of exponents. And if you recall, you had a power to a power rule back in pre-algebra, algebra 1 days. And it states that if you had a power raised to a power, you just multiply those exponents together. So this would be 4 to the 3x. And so that is your final g of f of x. And again, we've got to state the domain. If we were to put this into a graphing calculator to see the graph, we would find a graph kind of like this. It's an exponential graph. X is continuous in both directions. So x would, once again, just like many of the others, be all real numbers. So I hope this gave you a good introduction to the lesson. Make sure you show your work, kind of like what I've done in this